So, following on from Jeff, in the spirit of a workshop, I don't have a very nice set of slides organised. I'm going to be flicking through different things, and I can't go into a lot of detail, but the substantive work in here is stuff that's already been published. It's on my website, so I won't go into a lot of technical detail, but I'm kind of talk about things that currently are interesting and how I see them in the scope of what I've already done. So that's my excuse. Okay. So what am I interested in at the moment? I think here are some conjectures, themes, ideas. In human society, and increasingly in social network sites, I think it's becoming people are becoming aware that friendship or trust networks that link together people who trust each other are very powerful. And possibly a new way to gain positive interactions between individuals. What I'm interested in is not just producing systems in which everybody trusts everyone, but more like in the context of a network, finding chains or routes of trust between distant nodes. Okay, if you can do that, then this can operate, I'm claiming, as a kind of distributed reputation system. So what do I mean by that? Well, what I mean is a traditional reputation system to me is something where somewhere there's some kind of stored list of nodes or individuals and some reputation evaluation against them, or it's generated in some way. Whereas what I'm trying to say, and in a way it's similar to what Jeff's saying in a way, what I'm trying to say is from the network structure itself, at a given time, you should be able to use that to get the function of a reputation system without calculating it. I think it's not controversial to say that humans seem to be able to produce these trust networks endogenously. People don't tell you who to trust. You generate these over time through interactions. And it's those kinds of networks which lead to, say, events like this happening. These possibly informal social networks based on trust. So when you create these kinds of trust networks, they're based on ongoing interactions. So I'm interested in what kinds of ongoing interactions could generate trust, what kinds of simple, possibly, individual behaviour could create and sustain these trusted networks, particularly those that have long chains of trust between nodes, or at least some chain of trust between all nodes. Now, these kinds of networks are potentially very valuable. For example, they could be used, the claim is, to replace the current global money system, for example, which is based on a hierarchical system of credit going up to central banks and down to local banks. So this is something that I only found out about recently, and I think this is really interesting. There's a project which I'm not involved in, called Ripple, which is an attempt to create P2P money through these trust networks. So I was going to draw a nice diagram, but I haven't had the time. So what we're talking about here is if you have like some set of nodes, people, okay, and they have some a priori trust links. Maybe they're friends already. This might be you. Alice, this might be Bob. They know each other. The idea might be that they could put some credit that they would be prepared to give to their friends. This is true. If you go out to dinner with your friends and, oh, he's forgotten his wallet, you might be prepared to lend him so many 50 euros, 100 euros. If it's family, it might be going to thousands of euros. And in fact, in poor countries where there is no easy currency available, there's been a lot of anthropological work that shows that informal credit networks, often based around local shops, keep the economy going. Okay, usually through family ties. Okay, so what's the big idea? Well, it's a simple idea, really, which is obviously if you know someone directly and you can award them credit, then there's no problem here. The trust exists already. But the point about an economy is you're often interacting with people you don't know and you don't trust, okay? So the simple idea here is if you have a network that's large enough that contains a large number of people in a community, or even globally, then if this node wants to make some economic interaction with this node, then it's possible to do that even if they don't trust each other, as long as a chain of credit can be found, okay, between those two nodes. Then an economic interaction can occur between those nodes based on a series of loans occurring between trusted friends. It's a simple idea, right? This is how banks currently work. Okay, if you imagine these nodes as banks, this is how banks currently balance their books. That's why currently in the UK anyway, and in America, there's been a squeeze because banks have stopped trusting each other. That's the basic idea. But the idea here is that with peer-to-peer technology, everyone could be a bank. Okay? So the idea is that the reason why this requires peer-to-peer technology is in order to facilitate, find this route and facilitate this chain of lending is not something that you could do easily with pen and paper, because these people could be all over the world. But it can be done on a computer automatically and transparently. Okay, so you may be facilitating transactions between two endpoints that you don't know anything about, but it will ultimately come down to borrowing money and lending money to friends. So this is just something I recently came across, and I just find this very interesting, because what it's saying is chains of trust are important. It's not just important to trust a lot of people. You can maybe trust a few people, but as long as you can build chains between two distant nodes, you can get some very interesting properties. So this Ripple project that I only found out recently already has a beta server where you can create an account and you create a social network, and on each link of that network you put a value that you're prepared to lend money to that amount in any currency you like. You can even put interest on. What's interesting about this is you could actually eliminate interest in the borrowing system. So I think that's really interesting, because replacing the world global economy is a sort of fairly profound idea, which is coming from P2P. So, you know, it's a big idea. So the question I'm interested in then, to come back to something more sort of down to earth, is, so can we capture, since we realise that creating and sustaining these networks of trust, it's all very well saying, well, people have friends and you know, they can lend some money to them. Can we actually capture that, endogenize that in some kind of simple algorithmic way that allows nodes to create these networks artificially, that give us some understanding of how we can do this without just relying on humans to contribute the trust a priori, and that could be useful for automatic P2P applications. So now I skip to something else. So going back to the first talk by Bernardo Huberman, there he was talking in his brief P2P section about how you can create effectively incentives for individuals to share things where there might not normally be incentives to do so. And the way he did that is by introducing money. And because when you introduce money, what you're doing effectively is then you have to assume that individuals are rationally trying to maximise money. You're introducing money from outside the system. You need a central payment system, etc. There are other ways of doing this. And one of them is like by creating these chains, which I'll talk about. And this is a recent thing, which is a deployed peer-to-peer client, which is based on BitTorrent, called Tribler, and this uses bandwidth as currency as a way of creating the kinds of incentives. So you don't need necessarily to import money into a system and all that and assume rational incentives. You can use other kinds of incentive mechanism, and the basic idea is it's a bit like this kind of thing, but instead of dollars, you're talking about bandwidth that you're prepared to lend to a friend, and then you would expect that to be reciprocated later. So the idea of Tribler is you build what they call tribes, which are essentially friendship networks, okay, based on persistent IDs, where each node records how much bandwidth they've contributed to their friend previously, and there's a balancing of the books over time. So it's a kind of economy of bandwidth. But currently it's limited to disconnected tribes, and again, you have to say, this is my friend, and he will help me download a file, and I will help him. So again, this is like exogenously done. Tribler.org. You can actually, what's going on now, so this is a bit of a promotion, although I've not been involved in this, but I'm moving to the place that are involved in this very soon. There's actually an experiment, I think, still going at the moment, where you can download 2 different versions, and if you go to the website, you'll click and you'll get, if the experiment's still running, you'll be asked to download one of 2 versions. But I'm not going to tell you what the idea of that experiment is, because it could bias your choice. Okay, so basically, what I've been doing for quite a long time is looking at these new, if you saw Carl Sigman's talk, plenary talk, he talked briefly about these new group selection models to create cooperation in evolutionary kinds of economic situations. What I've been trying to do is get some of those models and get them into a network so that we can create these kinds of trust networks spontaneously. Okay? All these recent group selection models, and I'm going to rush through them. How long do I have?
7 minutes.
Okay, so I'm going to go through them quite quickly, but there's references at the bottom you can look up if you're interested. All these group selection models are not really group selection in the traditional old sense. They're actually models of individual selection that create dynamically social structures which look like groups, that then constrain the individual selection to produce group level benefits. So it's not that the group itself is being reproduced or selected, it's that the individuals are being reproduced and selected to create groups. Maybe it's a silly distinction, but biologists can get very upset when you talk about group selection if you don't mention that. Okay. The point about these models is they don't require reciprocity in the tit for tat way, although you could claim the social structure is a kind of reciprocity. I'll skip that. There's been a whole set of models based on this tag concept, and by tag I don't mean folksonomies. Okay, I mean something totally different. Tag models essentially create arbitrary groupings which evolve over time, eliminating free riders, because groups that have less free riders in them tend to contract, and groups that have more good guys in them tend to expand. So what you end up with is a kind of dynamic ecology of groups in which the individuals within them are predisposed to be incentivized, if you like, to be good guys, to pay their debts or to share bandwidth, whatever the application is. More recently, and there's been some work presented here by others, that there's been a network rewiring approach, which is where you take nodes and effectively, really, to put it in its simplest form, nodes move from the neighborhood they're in. They drop links if they're not happy. Okay, they're doing some interaction with their neighbors. If they're not happy, they drop links and they move to some other random region of the network. So there's a kind of simple learning process. What you find there is you get these groups of good guys forming, bad guys dissolve that group, okay, under certain conditions, right? And there have been more recent and different models like group merging and, well, group splitting models, where when a group gets a certain size it splits, but it's just another model. So we designed this algorithm called Slack, which can be proposed as a P2P protocol, but you can see it as a simple mechanism that captures how you might create these chains. That's basically the algorithm, right? So the basic idea here is that each node periodically is performing some activity which generates some utility. This is not discussed here, it could be anything. I'll show you what we get when we play the prisoner's dilemma, which is a classic game to test cooperation. But periodically nodes select a random peer. If they see that peer has a higher utility than them, then they drop their current links, they link to that peer, and they copy its strategy, its behavior. So this is an evolutionary approach, okay? Now, if you do, I'll go through all this. If you do this, then in this case, nodes are periodically playing the prisoner's dilemma with neighbours. So that would equate in a way to defection in the prisoner's dilemma would be a bit like not paying your IOUs. Okay, a similar kind of thing. And this is the sort of thing you get. So where the blue guys are bad guys. So if you start from all bad guys, eventually through mutation, through some sort of localized innovation, you'll get some good guys. That group is very attractive, so everybody joins. Then some bad guys get in through innovation, exploit that group, it splits apart. But the basic idea is from a situation of all defection, using that simple Slack learning rule, you'll end up with cooperation in the prisoner's dilemma, which is the opposite of the Nash equilibrium. It's not the Nash equilibrium, okay? But it's very useful. Now, coming back to what I was talking about, that Slack algorithm produces disconnected components. By putting a probabilistic link drop, instead of dropping all links when movement occurs, putting a probabilistic link drop on, you can get a small world topology, okay? And that's useful to create these chains of cooperation. And I can give, how much time do I have now?
About 2 minutes now.
About 2 minutes, very conscious. I can show you, so you see the original Slack would produce these cooperative components, but obviously for things like this, where you want to be able to have a chain of trust between different nodes, you need something connected together. We called that Slacker because it was just a probabilistic drop. Now, what we did is we took a measure here called cooperative connected path. So if you take any network and you can determine if each node is a cooperator or a defector, then the cooperatively connected path measure is just the probability that any two nodes in the network can find a cooperative path between them. Yeah. So, put another way, you take every pair of nodes, okay, and search for a cooperative path between them, and average that over the entire network, which gives you the probability that any two nodes are connected by a cooperatively connected path. Okay, so what you see here is you get high cooperatively connected path values over large range of network sizes. You get small, it's a small world. You've got a low average path length and a high clustering coefficient. So we get small world networks with a high cooperatively connected path length. Now these are just that's just a time series, but it's less interesting. These are just based on interactions where neighbours interact through playing the prisoner's dilemma. They don't interact in some more sophisticated financial way. But I don't see any reason why a similar rule couldn't be used to construct artificial credit networks, be they with bandwidth or even real money. Okay, that's it, 1 minute left. So finally, this is just new stuff that's even weirder. So I've got this model, this really simple model of nodes, and I'm saying maybe this is similar to how humans behave. And people will say, well, is it? So I started doing some experiments, some joint work with a guy in the psychology department at the University of Plymouth, where instead of these simple nodes, we give the same basic structure, game structure, but we put humans in, and we see what happens when we give them the ability to move between groups in the same way, to rewire their neighbourhood, or when they can't, when they have to play games with random neighbours. And we don't get as high cooperation as we do in the simulations, but we get statistically, well, there's more work to be done, but it looks like we get statistically significant increases in cooperation when we allow this underlying process to occur. I can't go into all the details, but essentially the main difference really is between illusory groups and dynamic groups. What we did at first is this And then we did this, and we thought, great, there's a big increase between the first two, but it turns out in psychology there's a well-known thing called in-group bias. Just telling people they were in groups made them cooperate more, even if the underlying game was the same. So if you just tell people you're in a group, and there are these other groups, they immediately cooperate more. So the illusory group, the situation is a comparison of just telling people they're in groups, giving them exactly the same information as in the dynamic groups, but actually the underlying game is the same as no groups. So maybe people do actually behave in this way. So this could be a new mechanism for promoting cooperation between humans as well. So I've got to stop now. Thank you.